Hi ladies and gentlemen, this is Mr. Green and this is another in my series of lessons on geometry. Today we're going to be taking up lines in space. Well, lines and planes, but it's not quite the same as that, but it's going to be interesting, okay? Where should you be? These are the last lessons in Unit 1, so look for a review in the Class Connect, and we're going to be getting close to taking the test, the unit test. So don't forget, make any quiz corrections you've got out there to be made. And don't forget, after 28 days, we do lock things down so that they're closed out. Okay, so where are we talking about? Lines and planes in space. No, not really. What we're looking at here is our three-dimensional graph, three-dimensional grid like this, right? And when we have a plane or a line in space, well, what are we talking about? We're talking about in this three-dimensional grid system somewhere. There's a point there, there's a point there, and there's a point on the third axis. And when you connect these together, what you get is a plane, or at least the representation of a plane, sitting in that three-dimensional space. Okay? Now, this isn't like a wall that's in your room that goes up and down. Those would be more like the axis and the planes of the coordinate system. This would be like taking I don't know, taking a piece of wood and setting it in the corner of your room. That plane that kind of sits there kind of offsets everything. That would be a plane in space. Okay? So what are we looking at? We're looking at the places where this plane intersects the axes. Okay? This would be an x-intercept, a y-intercept, and a z-intercept. There's three places where it would intersect that. Okay? So this is an equation for a plane. And the way that you find and graph a plane like this out is you're thinking, well, I want to find those intercepts. So first thing I want to find is the x-intercept. Okay? That's when y equals 0 and z equals 0. So if I stick those into this equation, I get 8x plus 0 plus 0 equals 24. Divide by 8, x is equal to 3. If I do the same thing for the y-intercept, okay, that's when x is equal to 0 and z equals 0. So what am I going to get there? I'm going to get 0 plus 12y minus 0 equals 24. Well, that's when y is equal to 2. And if I'm looking for the z-intercept, that's when x is equal to 0 and y is equal to 0. And I stick that in, I get 0 plus 0 minus 6 z equals 24, or z is equal to negative 4. Well, now that I've got those, I can actually plot them on here. I'm going to go 1, 2, 3, x-intercept at 3. I'm going to go z is equal to 2, 1, or y is equal to 2, 1, 2. I'm going to go z is equal to negative 4, 1, 2, 3, 4, right down here. I'm going to draw a line connecting all three of those points together, just like that. And what do I got? Looks like I got a plane that kind of goes downwards to hit the axis. Now, a plane obviously goes in all directions. We're representing a plane with a three-sided figure. Why? Because we have three axes. We have a three-sided figure that goes on there. Okay? So, here's a plane. It's already graphed. And it says, graph the equation by finding the y-intercepts. That's what we just did. I found the y-intercepts. I located the y-intercepts where they cross the x, y, and z axis and graphed it. And there's our plane. Okay? So, if I was asked to write an equation for this particular plane, first thing I'm going to do is I'm going to find the y, x, y, and z intercepts, okay? X-intercept, 1, 2, 3, 4. That's at 4, 0, 0. Y-intercept, 1, 2, 3, 4, 5. That's at 0, 5, 0. Z-intercept 1, 2, 3, 4, 5, 6. That's at 0, 0, 6. So I've located each one of the 3 points that are on here. What can I do with this? Well, 3 points, I've got the general equation for a line, for a plane. General equation for a plane. It's AX plus BY plus CZ equals D. That's the general equation for a plane. I can take each one of these 3 points. If I stick 4, 0, 0 in for X, Y, and Z, what am I going to get? I'm going to get 4A is equal to D, or A is equal to D over 4. If I stick the y-intercept in, I'm going to get 5B is equal to D, or B is equal to D over 5. If I stick the z-intercept in, I'm going to get 6Z is equal to D, or Z is equal to D over 6. All I did was solve for my A, B, and C by using the X, Y, and Z. Now that I have equations for A, B, and C, I can replace it in that equation. So D over 4 times X plus D over 5 times Y plus D over 6 times Z is equal to D. You know what? There's a D in each one of these, so I can divide that completely out, and I get 1/4 X plus 1/5 Y plus 1/6 Z equals 1. You know what? I need to find a common denominator amongst all these down here. And I see here, I'm going to choose 30, 60. Okay? 60. What do I got to multiply 4 times to get 60? That'd be, nope, 15. 15 times 4, 60. Yeah. So that would be 15x plus, I'm going to have 15x over 60. Common denominator here. I got to multiply this one times 24. 24y over 60 plus, I don't care, 10z over 60 equals 1. Multiply through by the 60. 15x plus 24y plus 10z equals 60. There's my equation. Okay? Now, it's probably worth running this tape several different times to make certain you understand how to do this. I can guarantee you're going to see problems like this again. You want to make certain you understand how to work these type of problems. Okay? Now, once I've got the planes, we can talk about the lines that form the edges of these planes. What are these lines? These lines are called a trace. Okay? Trace. It's nothing special about them, okay? 15, 24, and 10. Thank you. So we've got the equation of this plane. 15x plus 24y plus 10z equals 60. Right? We've got the equation for that plane. To find the equation of a trace on the xy axis plane, the trace is going to be the x term, the y term, but not the z term. So it's going to be 15x plus 24y equals 60. The trace on the xz plane would be, well, we got x and z's on it. That means we just got to leave the y's out. 15x plus 10z equals 60. If I now want to use the y-z plane, I can leave the x out. 24x plus 10z equals 60. Can you see what I did? I left one term out of this plane, equation for the plane, to get the equation for the trace. Trace, again, is that line that's on the plane here, and one of the two hits the two axes. Okay? So, this has been a hard topic. I guarantee you probably have some questions about this. I'll be in my room on Tuesday for tutoring, but I will be gone for the rest of the week because I'm in Dallas. But I look forward to hearing from you. If you have any questions, send me K-mails and we'll respond as quickly as we possibly can. Okay? I do appreciate the fact that you tell me that you're in geometry every time and what section you're in. Helps me answer your questions a little bit easier, okay? So, secret word for this video is plywood. I will talk to you later.